Our next topic is scalar product, dot product, or inner product. These are the three names of same product. In mathematics, these three products are taken as same. For example, 2 into 3, it will be equal to 6. 2 into 3, it will be equal to 6. 2 multiplied by 3, it is also equal to 6. But in physics, all three products are different. This type of product is written, first one, this type of product, that is with parenthesis, this type of product is written when we multiply a scalar with vector and the result is a vector. This type of product is written when we multiply a scalar with vector and the result is a vector. And its example is scalar is mass, which is multiplied by velocity and the result is momentum. This is vector, this one is also vector. This type of product is written when a vector is multiplied by a vector. Vector multiplied by vector, but result is scalar. Its example is force into displacement, both are vectors, and the result is work, which is scalar. Third one, when a vector is multiplied by vector and the result is vector. For example, we multiply moment r with force and the result is torque, which is also vector quantity. So these three products are different in physics and they are written for different cases. Here we shall study scalar or dot product. How is it represented? For example, if we have two vectors, let's say this is vector A, this one is vector B. If we are multiplying these two vectors, we are taking their dot product, then A dot B will be equal to A into projection of B on A. Projection of B on A. Or A dot B will be equal to A into B cos theta. Projection of B on A means that how much this component is, how much this vector B is on A. This is known as projection of B on A. How much this vector is on A, that is known as projection of B on A. Similarly, if we take the reverse of this product as B dot A, it will be equal to B into projection of A on B, which will be equal to B into A cos theta. But result will again be same because we have already discussed that result of dot product is scalar. So it will be, if let's say it will be 17 here, then again it will be 17, provided that the two vectors are same. What are the examples of this product? So we shall discuss its examples. Number one, work is equal to force into displacement. This is the first example of this scalar product in which we multiply two vectors and result is a scalar. Second example is power, which is equal to F dot V. We multiply two quantities which are vectors, force and velocity, and the result is a scalar, which is power. let's discuss some characteristics of this product. This product has number of characteristics that these two vectors may be parallel to each other. These two vectors can also be anti-parallel. These two vectors can be perpendicular. We can also take the self product of a vector. So let's discuss these different conditions, that what are the possibilities of these two vectors. Number one, if A and B are parallel to each other. If A is parallel to B, then if two vectors are parallel, then theta is equal to 0 degree. Then angle between them is 0 degree. So we can use that in this formula. Then A dot B will be equal to AB cos 0 degree. A dot B will be equal to AB. What is the result? This means that when two vectors are parallel to each other, then their dot product is simply equal to product of two vectors. How? If vector A is vector A is uh, 5 Newton, let's say its magnitude is 5 Newton, vector B is equal to 6 Newton, then their dot product, if we are trying to find their dot product and two vectors are parallel, then A dot B will be equal to 5 into 6, which will be equal to 30 Newton. Number 2, if the two vectors are anti-parallel, then theta is equal to 180 degree. So A dot B will be equal to AB cos 180 degree. A dot B will be equal to minus AB, because cos 180 is equal to minus 1. Now what results can we take from this equation? That when two vectors are multiplied, their scalar product is taken and both the vectors are anti-parallel to each other, then their magnitude is equal to negative of the product of two vectors. For example, it was 30 in previous case, now it will be minus 30. So just this minus sign shows the that the value has decreased. It is now in negative values. So this product, because here this negative sign does not show any change of direction, because result is scalar, so it cannot be the change of direction. It just shows that value, total product, has been decreased. Number 3, if A is perpendicular to B, if vector A is perpendicular to B, then what will be the result? That A dot B will be equal to AB cos 90 degree. As cos 90 is equal to 0, so A dot B will be equal to 0. This will be the result, which means if two vectors are perpendicular to each other and we take their dot product, then the result will be 0. Now let's talk about their components. If we talk about unit vectors, then in case of this first condition, the two vectors are parallel to each other, which means if we take the dot product of two vectors, such that they are parallel for unit vectors I, j, k. Then I dot I will be equal to j dot j will be equal to k dot k, which will be equal to 1. And if the two vectors are perpendicular to each other, in that case, for example, this one, we are talking about this case because I is perpendicular to j, which will be equal to j dot k, which will be equal to k dot I, and all other reverse possibilities, for example, j dot I, k dot j, and I dot k. In all these cases, the result will be equal to 0. We shall also make use of this result in our last characteristic. Fourth one is, if we take the self product of a vector, for example, if we have a vector A, we take its dot product with it, then it will be simply equal to A cos theta, which will be equal to A square cos 0 degree, or which will be equal to A square, A dot A. This means that when self product of a vector is taken, in fact self scalar product of a vector is taken, then the result becomes the square of that vector. And if we want to find this angle, let's say this angle is unknown, then we can also use the rectangular components of a vector. Let's say that we have a product A dot B is equal to AB cos theta, or it can be written as, if we write these vectors in the form of components, then A will be equal to AX plus I plus AY J plus AZ K dot BXI plus BY J plus BZ K. It will be equal to AB cos theta. Here we have seen that when vector I is multiplied by I, result will be equal to 1. But when it is multiplied with j, then result will be 0. It means this component AXI will only be multiplied by this one. We shall also multiply it with other components, but result will be 0. So we can write it as AXBX. AXBX I dot I, it is equal to 1. So we can multiply 1, or we can leave it. AYBY plus AZBZ is equal to AB cos theta. Now we can solve it here. We are trying to find this angle. So this angle cos theta will be equal to, this AB is multiplied with cos theta, it will be divided on this side, so it will be equal to AXBX plus AYBY plus AZBZ divided by AB. So this is the final result if we want to find the angle. So these are the 5 important characteristics of scalar product. And remember that the result of scalar product is a scalar quantity, and it is a product in which two vectors are multiplied. Thank you.